Okay. Here we go. Starting to go. Yeah, it does. I'm going to judge the Son of Thor competition in March. You guys know what Son of Thor is? So they had me fill out this bio. Oh, you did this class? He's my lookalike.
Yeah. And your role model.
Role model. I don't know if you could call him a role model. Because he's perfect. I guess you could aspire to perfection. Yes, he's a role model. Anyway, about this.
Have you ever seen his acting?
This is going to be kind of hard to draw, so I want you to just to watch.
Oh, joy.
Do you remember what I said Radian sounds a lot like? Radius. So check it out. This is a radius, right? So they're taking the radius and wrapping it around the circle. That forms 1 radian. Okay, watch it again. Well, first of all, what is this called right here? That's the radius. So all they did is took that exact length and wrapped it around the edge of the circle. That's equal to 1 radius. Watch it again. Whoa, cool. There's 1 radian. Now 2 radians, if they did this exact same length again, wouldn't 2 radians end about right here? 3 radians would end maybe about right here. So 3 radians doesn't quite get us to half a circle. It's 3 plus a tiny bit more, isn't it? What's a number you guys know of that's 3 plus a little bit more? So check this out. 180 degrees is half a circle. 3 radians plus a little bit more equals pi. So a half of a rotation is 180 degrees, or pi radians, yay! Yeah, the circumference is 2 pi r, because all the way around a circle. Well, let me ask you this: half of a circle is 1 pi radians. That's what it says here. Yes. So what would a full circle be? 2 pi radians. That's where the circumference formula comes from. Is 2 pi r. Anyway, let's get back to your notes. Now I want you to draw a circle. Locate the center of the circle. Draw a radius. And then, as best that you can estimate, take that length of your radius and wrap that same length around the edge of the circle. This is called 1 radian. Now the nice thing about this is it doesn't matter the size of the circle. 1 radian is going to be the same on a large circle or a small circle. Let me see if I can actually draw.
Do you actually draw or just click a button?
I can draw this. I'll even close my eyes. A larger circle here. Oh boy. Pretend that never happened. We need a different color. What color do you guys want?
Purple.
Pink. Alright. So if I drew a larger circle here. And then I found the radius. And then I took that exact same length and wrapped it around the edge of the circle. That would give me the exact same angle measure. This is 1 radian. This is 1 radian. But isn't it the exact same angle measure? Yeah. So it doesn't matter the size of the circle. You get 1 radian is 1 radian. It's just this little portion of a circle. Okay. You with me? And then you need to write this very clearly in your notes. 180 degrees was equal to how many? That's all the way around. 2 pi was all the way around. Wasn't it just 1 pi or pi? So 180 degrees is equal to pi radians. You must write that.
We decide about how we look.
Isn't that the first symbol you think of when you think of pi?
Think of a circle.
So they should have made it like this. Would that be the symbol for pi?
Or bad.
Or Pac-Man. Anywho, this is something that you guys...
Yeah, I did see that commercial too, that Pac-Man beer commercial.
Does this look familiar? If I wanted to change 746 seconds into minutes, isn't this what you guys do in a chemistry or a physics class? And my last class was trying to explain to me how the train tracks work. I thought you just drew a train over here. That's a train, by the way. But no, you draw these weird lines. Is this what the train tracks thing is?
This is the brainwashing of the try to teach.
Well,
This is the
yeah. I mean, if you know the train tracks, it works. But really, all I gotta do is 746 seconds. You need to multiply that by a fraction where seconds is on the bottom and minutes is on the top. Why does seconds have to be on the bottom? So you cancel that unit of measure and you go into a new unit of measure. 1 minute is equal to 60 seconds. This is just called dimensional analysis. You do a lot of it in a science class, but the point here is this. If it was just 1 divided by 60, that's a pretty small number. But it's not 1 divided by 60, it's 1 minute divided by 60 seconds. What is 1 minute divided by 60 seconds? Isn't 1 minute the same as 60 seconds? So let me ask it again. What's 1 minute divided by 60 seconds? 1. And if I multiply 746 by 1, am I changing the value of 746? I'm just changing how it's measured. I'm not changing the value. You guys understand how this works? All this really is equal to 1 because it's something divided by itself. That's exactly what we're doing with radians to degrees. So, as an example here, convert from degrees to radians. Write this down. And then in a second we'll do from radian to degrees. But let's say that this is 30 degrees. So just like with that other problem, we need to multiply this by a fraction. And the fraction has to have the same value on top as it does on bottom. Not the same numbers, just like we had 1 minute and 60 seconds. They're not the same numbers, but it's the same value. And we have to use this. 180 degrees is the same as pi radians. Those are the same values. But where does the degrees have to go? On the bottom, because we're trying to cancel the degrees. So 180 degrees goes on the bottom. Now instead of writing the whole phrase pi radians, just put pi. The lack of degree symbol implies that this is radians and not degrees. What's that? Usually R represents radius. That's why they don't want to use an R, because you get confused. Well, you can cross out the degree symbols, because you have one on top and one on bottom.
Like when people getting confused.
Yeah. And now we're in radians. The degrees are canceled. So this is equal to 30 pi over 180. And then you simplify the fraction into 3 pi over 18. And you continue to simplify. 3 over 18 is 1 over 6. So it's 1 pi, or just pi. You don't need 1 in front of it. Pi over 6. So if I asked you to graph 30 degrees angle, and then I asked you to graph pi over 6 radians of an angle, it's the exact same thing. They're the exact same angle. One is measured in degrees, one is measured in radians. So now let's take a look at the other direction. Write that, convert from radian to degrees now. And this is not just some obscure thing that you never see. Radians are actually way more widely used than degrees. You use degrees for things like triangles and rectangles, which is like junior high type math. In the real world of mathematics, radians are king. So this is pretty important.
Why don't they have their own letter?
They're so important they don't even need a letter. That's what it is. So anyway, we have a radian measure of... Did you just start writing?
Then they're fighting with
Would you rather read my book?
did your homework half as well as you talked, you'd be getting A+ right now. Pi over 4. How do we know this is in radians? There's no degree symbol. And, I mean, usually the pi is a dead giveaway, but there's no degree symbol. Okay? So we got to do the same thing. We need to multiply this. And we're going to use these same values, but it's not going to be pi over 180 anymore. We don't want to cancel the degree symbols. What do we want to cancel? We want to cancel the pi. So pi goes on the bottom, and 180 degrees goes on top. So the pi symbols cancel. You have 180 divided by 4, which is 45 degrees. And this is just dimensional analysis, like you would do in a chemistry class. So get your books out. To page 396.
Got it.
The problem 1, got it? Do all 4 of them. A, B, C, and D. The problem 1, got it. Part A, B, C, and D. Well, do A and B and D definitely. C might give you a little trouble. You can try it. But do part A, part B, and part D definitely.
Okay, yeah, wait. 1, 2, 3. Calm yourself.
Okay, I need
Yeah, I know. 84.
let's see. Let's have a guy come up for the first one. Part A.
Oh, come on, this is an easy one. Pi over 2 is what you're supposed to.
Nothing, huh? That's always coming up. We need somebody to be brave like Jordan. Who's brave like Jordan? Mason, all right.
Really?
You're not brave like Jordan? Well, come up here and be brave. You had a good start. Bring your paper. You wrote something. I saw you. Get as far as you got, and then we'll help you.
Well,
Okay. Step up to the side for a second. What can you now do?
cancel the pi.
You have a pi on top and a pi on bottom. So cancel the pi. You have a pi on top and a pi on bottom now. So those cross out. Look at that. You see, you did it. Thank you.
90 degrees. Now, just so we're clear, Mason, why did you do 180 over pi? Why does the pi go to the bottom? So cancel that pi, right? Okay, good. All right, we need a lady.
Oh, now they're at
For part B. I saw a lot of you had the right answer, ladies. Come on. I can choose. I hate choosing. I'd rather have a volunteer. Was it really that scary up here, Mason? Was it that scary? See, it's not that scary. We're all nice. You want to try it? Alrighty. Thank you. We gotta be brave like Jackie.
Oh, Jack.
Or Jake Quallen.
She did it for chemistry.
Chemistry? What's one of the chemistry teachers? Shout out to Bastion!
Potter.
5 pi over 4. That's what I would have gotten. Is that what you guys got? Thank you. Nice job. Okay, part C was a bit strange, so
I got 40.
check it out.
45.
So part C was 2 radians. You guys, this is much different than 2 pi radians. This is just 2 radians. You guys with me here?
So could you just write 2 pi?
So if we went back to our circle, here's 1 radian. There would be a second radian right there. What kind of angle does this look like? This is 2 radians. In degrees, what does that even look like?
About 120.
Maybe about 120. Okay? So the way that you do this is the same way we've been doing everything else. If we want to cancel radians, then don't we have to put the radians down at the bottom?
Yes.
Isn't pi a radian measure?
Yes.
And then we have to put the degrees on top, 180 degrees. Now the difference here is this pi symbol doesn't cancel with anything over here, so you just have to leave pi in it. Okay? So you get 2 times 180, which is 360, divided by pi, and this is in degrees. So I have to put a degree symbol here, and that's about 114.5 degrees. Right, Brian? You causing a distraction back there that would cause them not to learn this?
They're saying racist things. They're saying things about noodles now.
We have some empty seats over around here if you want to
I'm good.
leave that situation.
I'm good. I'm all good.
Okay, part D, what was it, 150? What was the question on part D? 150? Okay, well, where does the degrees have to go? On the bottom? So that way the degree symbol can cancel out. You have 150 pi over 180, which is 15 pi over 18, which is 5 pi over 6. Okay, go to your unit circle. Oh, it's blank.
Oh no.
Yours is not blank, hopefully, by now. So, we filled in all the degrees, yes, last time. But we didn't do these blanks next to them. Guess what those are?
Negative.
Good guess. But no, they're the radians.
That's what I wrote.
You put the negatives there?
Yeah, you told us to fill it out.
Except for those.
It's okay, right on the other side. You just said to go.
When do you ever listen to anything I say?
Kind of true.
Alright, these are supposed to be the radian measures.
Oh.
Okay? So, 0 degrees is 0 radians. What about 180 degrees?
Just proves that we one resistance.
What 180 degrees was?
1 radian?
1 radian was right about here. Pi radians, wasn't it? Well, what about 90 degrees? Isn't 90 degrees half of 180?
Half pi?
So shouldn't this be pi over 2?
Yeah.
And isn't 45 half of 90?
Yeah.
So what should this one be?
Pi over 4?
Pi over 4. Alright, now if we had time and I really wanted to torture you, I would make you go all the way around the unit circle and convert each one, like 60. You would have to multiply that by pi over 180, and you would get you'd get pi over 3. We don't have time for that.
Let's get the third.
Well, we'll get back to that. I want to show you guys a pattern here. You guys like patterns, don't you?
Sure.
Okay, 30 degrees, I'll just tell you, 30 degrees is pi over 6. Now for the time being, I'm going to skip all of these lines in the middle, and I'll show you why in a second. So I'm going to skip over all of these. I don't want you to cross them out because they are important. But think about this. This is 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6. What is 2 pi over 6? Pi thirds. And what's 3 pi over 6? Isn't that just pi halves?
Yeah.
So you do see the pattern here? 1 pi over 6, 2 pi over 6, 3 pi over 6. So what would the next one be?
4 pi over 6.
This would be 4 pi over 6, but that simplifies to 2 pi over 3. Now we're skipping this middle one here, so the pattern has to go to here. So we had 4 pi over 6, so then this one would have to be?
5 pi over 6.
5 pi over 6. And then we have 6 pi over 6, but what's 6 pi over 6?
Pi.
That's just pi.
12 pi.
So we had 5 pi over 6. Here we had 6 pi over 6. So what would the next one be?
7 pi over 6.
7 pi over 6. That's 210 degrees. Skipping over 225 to 240. Wouldn't that be 8 pi over 6?
Yes.
But that simplifies to 4 pi thirds. I know I'm moving a little quick here, but are you guys understanding what I'm doing? If this is 8 pi over thirds, then wouldn't this be 9 pi? Or sorry, if this is 8 pi over 6, wouldn't this be 9 pi over 6? Or what is that? 3 pi over 2. And if that was 9 pi over 6, that makes this 10 pi over 6. But that's the same as 5 pi over 3. So we had 9 pi over 6. We had 10 pi over 6. So finally, we have 11 pi over 6. Well, I guess not finally. We have one more. 11 pi over 6 would become 12 pi over 6, which is 2 pi. And isn't that what we said what a full circle is?
Yeah.
360 degrees.
Could you like to zoom out?
This is far out zoomed as I can do.
Go to the top line. Okay.
Now with these middle ones, there's also a pattern with those. It's pretty close. This would be 1 pi over 4. This would be 2 pi over 4. So that in the middle here you would have 3 pi over 4. And then at the very far end you would have 4 pi over 4, which we already know is 1 pi. So then if we had 4 pi over 4 right there, this one would be, come on now, 5 pi over 4. Right here, which is just pi. And then this one turns into 6 pi over 4, but we already know that's 3 pi halves. That's the same thing. Okay. So if this was 6 pi fourths, then this one is 7 pi fourths. Okay. So that's just a big pattern, you guys. The whole dang unit circle is one big giant pattern. Right? And I didn't show you this last time, but I want to show you now just before we leave here. What do you guys have written right here? And what did you have written right here?
0, 1.
0, 1. Now check this out. Starting from the top, just looking at the x values. You with me?
Yes.
Starting from the top and moving down to the right. Do you guys agree that 0 is the same as the square root of 0?
Yes.
Is 0 the same as the square root of 0 over 2? Are those the same? You guys still with me? Now, instead of thinking of 0, if you think of the square root of 0 over 2, What if I increase that over here to the square root of 1 over 2? What's the square root of 1? And look at your unit circle. Don't you have a 1/2 right there?
Yep.
Yes, no?
Yes.
So then if the pattern continued, what would be right here? The square root of 2 over 2. And don't you have that there? What do you have? What should be the next number here? Is that what you have? Now if the pattern continued, what should be right here? Shouldn't it be the square root of 4 over 2? What's the square root of 4? 2 divided by 2 is 1. Now you can do the same thing going from this 0 and moving in this direction. 0 becomes 1 over 2. That becomes the square root of 2 over 2. What does that become up here? Square root of 3 over 2. And this will be the square root of 4 over 2, which is just 1. So the entire unit circle is just recognizing patterns. By the way, you're going to have a quiz on a blank. I'm going to give you guys a blank unit circle. Not next time, at the time after. You're going to have to fill out the entire thing from memory. No notes. Okay? Anything, and that's going to take forever. Does it need to take forever? This is just a big pattern, isn't it? It goes 0, 1 over 2, square root of 2 over 2, square root of 3 over 2, 1. And then it counts back down and it goes all the way around. Did I hear a bell ringing? No, we're still moving, you guys. We've got stuff to do. Then one more quick thing I need to tell you about. How did you guys do this problem on the quiz today? How would you have done that problem on the quiz? Isn't this 120?
Yeah.
What's the y value there?
Square root of 3 over 2.
So wouldn't the answer be the square root of 3 over 2?
Yes.
So now what you're going to see on your homework will be something like this. What's the cosine of 11 pi over 6? Well, do you have to convert this into degrees? I mean, you could, but isn't 11 pi over 6 right here?
Yep.
And what's the x value?
Square root of 3 over 2.
Isn't that the square root of 3 over 2? So just leaving it in radians, how would you answer this question? Square root of 3 over 2. You guys follow?
Yeah.
I got to make sure you understand this, so we're not done yet. What about this one? Sine of 3 pi over 4. What's 3 pi over 4?
135.
135?
Yep.
What's the y value there?
Square root of 2 over 2.
Square root of 2 over 2. Okay?
Yeah.
One more. I'm going to see if I get you guys on this one. You ready?
Yeah. Bring it up.
What's the cosine of negative pi fourths? Where's negative pi fourths?
Come on, you guys, think. So positive pi fourths is this way, right?
Yeah.
Negative pi fourths would be coming down here. This is negative pi fourths. It's the same as 315 degrees there.
Yeah.
What is it, cosine or cosine? I forgot what I asked you. So cosine would equal the x value there. So what is it? So that would be the square root of 2 over 2. Okay? That's all your homework's going to be, is evaluating trig functions when they're in radians.
Alrighty. Now get out of here. I'm tired of you.